Next thing we want to look at is the simplification, multiplication, and division of rational expressions. Now, first of all, what is a rational expression? Well, rational, if you remember the use of that word previously, basically just means can be written in a fractional form. So a rational expression is going to be a fraction, not just that contains numerical values, but contains polynomials. So a 3x plus 5 over an x minus 2 is a rational expression. A 5x squared plus 7x minus 9 over 3x plus 7 is a rational expression. Now, everything that you've learned how to do with fractions, we're now going to have to learn how to do with rational expressions. Now, if you stop and think about all the things that you have done with fractions, then you can get an idea of what we're going to do now with these rational expressions. With fractions, you had to learn how to simplify them. You had to learn how to multiply. You had to learn how to divide. You had to learn how to add. You had to learn how to subtract. And all of those things we will learn how to do starting with the simplification, multiplication, and division right now. Now, the first thing to remember with a fraction is there is one number that cannot go in the bottom or in the denominator of that fraction. A fraction like 0 over 3 can be simplified to 0. And so a 0 on top is not a problem. But a 5 over 0 is in fact undefined. So something we're going to have to be very careful about is making absolutely sure that we do not let any zeros end up in the denominators of our fractions. Now, as far as the simplification part is concerned, remember what you learned about simplification in the past. If I had a 35 over 45, you would simplify this fraction not by saying, oh look, the 5's cancel or something crazy like that. The cardinal rule is that you're going to have to remember and get really used to is that if it's not factored, it can't be simplified. If it's not a common factor, it can't be canceled out. So the 35 needs to be rewritten as a 7 times 5. The 45 needs to be written as a 9 times 5. The 5's cancel, and 7/9 is the answer. And again, with all of these problems we're about to do, the very first and the key, the crucial step, is going to be factorization if it's not already written in a factored type form. Now let's look at our first actual rational expression that we're going to simplify. Let's look at a 2x squared y over a 10x y squared. Now this is already basically in a factored form because it's not a binomial or a trinomial or something like that. So we can go through and simplify one item at a time. First of all, 2 over 10 simplifies to 1 over 5 because I divide out of 2. With an x squared on top and an x on the bottom, what will happen is this 1x will cancel one of those. We end up with an x to the first on top. Also with the y's, this 1y will cancel one of those. We end up with a y to the first on the bottom. Now, of course, all these 1's aren't necessary. We can just write this as x over 5y. But that is the simplified form of this rational expression. Now remember, we have to make sure that zeros do not end up in the denominator of a fraction. Now since these two are supposed to be equal, I will look at the original to decide what x and what y cannot be. And based on the original, I see that x cannot be 0 and y cannot be 0 because that would result in a 0 in the denominator of that fraction. Now let's try this again. And try it with one that needs some factorization. Let's look at x cubed y minus x squared y squared plus xy cubed over top of a plain old xy. And again, remember, factoring has to come first. Now the bottom is already in good shape. There's no addition, there's no subtraction, there's no binomials, there's no trinomials. Now on top, we got to go looking for a GCF. And it looks to me like an x will come out and a y will come out. That's going to leave an x squared minus xy plus a y squared. So the first thing we see after pulling out the GCF is that x will cancel x, y will cancel y. Since there's nothing left in the denominator, there's no point in trying to factor any further. I would do it if there was something else to cancel, but there's not. Again, this xy on the bottom would imply that x can't be 0, y can't be 0. Now, it will not always be 0 that we're eliminating as a possibility here. So let's take a look at another simplification. Let's look at a 3 minus x over an x plus 3 and an x minus 3. Now, we see 3 minus x and x minus 3 here, and this was an important point to be made. These two aren't identical, so they just can't cancel out perfectly as is. But they're very similar. Now, even though they're not identical, they are similar in the fact that when they cancel, a negative 1 will be left. The reason for that being left behind is that even though they're not the same thing, they're similar in that they are opposites of each other. So the basic rule is that a minus b and b minus a will cancel, leaving behind a negative 1. Now, of course, a plus b and b plus a are in fact the same thing, so when they cancel, you get a positive 1. All right, now, that's simplified. That simplification was easy because they factored it for us. But looking at the original denominator right here, x plus 3 would be 0 if x had been a negative 3. So I have to make the statement x can't be negative 3. Also, x minus 3 would be 0 if x was equal to 3. So I got to make the statement x can't be 3 either. Now these examples so far have been pretty straightforward, mainly because either factoring wasn't needed or it was already done in this case of this last example. The next thing we need to get into is some problems where we're doing simplification and the factoring is going to be our responsibility. So let's look at x squared minus 16 over x squared plus 3x minus 4. Alright, now, since nothing's factored, I can't do any canceling yet, so I'm going to have to look for the factorization. X squared minus 16 is a difference of squares. That one comes out easy. This is a trinomial with no GCF, so it's bound to be two binomials. X squared is x and x. 4 would be 4 and 1. To get the 3, I get a plus 4 and a minus 1. And again, factorization being critical, it's now done. X plus 4 cancels x plus 4. And your answer, basically with these types of problems, is whatever's left behind after you've done all the factorization and all the cancellation. Now again, looking at the factored form of the original, x plus 4 would be 0 if x was negative 4. So I have to make the statement x can't be negative 4 to prevent that from happening. And x minus 1 would be 0 if x was equal to 1. So I also have to say x can't be 1 either. So let's try one more of those types of simplifications. Let's try x squared plus x minus 6 over 2 minus x. Again, the bottom is okay. The top needs to be factored. X and x. And I believe we're going to have a plus 3 and a minus 2. Again, the point I made earlier, x minus 2 and 2 minus x aren't the same thing, but they are opposites. So they will cancel, and as a result, a negative 1 gets left behind, as well as the x plus 3. Also, 2 minus x would be 0 if x was 2, so I have to make the statement x cannot be 2. Now that's simplification. You're going to discover that with the multiplication and division, there's really not much more involved there than simplification. So let's get a clean piece of paper for our multiplication. All right, remember, when you multiply fractions, a over b times, say, c over d, you multiply straight across the top and straight across the bottom. But actually, in our problems, we won't do a lot of real multiplication. We'll spend more time doing cancellation than anything else. So if we had an x squared minus 2x over x, don't be tempted to cancel here, you haven't factored, times x squared minus 1 over x squared minus 3x plus 2. My first step has got to be factoring. In this first fraction, an x will come out of the top as a GCF. Of course, that bottom, there's nothing to be done there. In the next fraction, the x squared minus 1 is an x minus 1 and an x plus 1. Down here, it's a trinomial. Should factor into two binomials with an x and an x, a 2 and a 1, and a minus and a minus. So if you haven't really picked up on your factoring yet, you have to get it now. Now, remember with cross cancellation, it's from a numerator to a denominator. Not necessarily within the same fraction, but just from a numerator to a denominator. So, for example, x will cancel x. X minus 2 will cancel x minus 2. X minus 1 will cancel x minus 1. And x plus 1 is your result. Alright, let's try another multiplication. With the multiplication, again, cross cancellation is the key. In a lot of situations where you could have multiplied out an answer, they will often in the book just choose not to. But regardless of that, factoring is still critical. If we had an a cubed minus b cubed over a plus b, and we're going to multiply that by an a squared plus 2ab plus a b squared over an a squared minus a b squared. And again, the factoring. Now the a cubed minus b cubed is a difference of perfect cubes. So it comes out as an a minus b, a squared plus ab plus b squared. And of course a plus b is prime. The next one is a trinomial. It should come out as two binomials. A squared is a times a, b squared is b times b, plus plus means plus plus, and that does work. Next, we have a difference of squares. A minus b, a plus b. So here we go with the cross cancellation. A plus b cancels a plus b. Another a plus b cancels another a plus b. And no, it doesn't matter which one you use with which, as long as you go from a numerator to a denominator. A minus b cancels a minus b. Nothing left but the a squared plus ab plus b squared. So again, the multiplication is all about factor, cancel, factor, cancel. Now let's remember how division works. A over b divided by c over d becomes a over b times d over c. So in other words, we're going to do division as a multiplication problem once the reciprocal has been put into place. So, if we had an x squared minus 6x plus 9 over x squared plus 3x, and we wanted to divide that by an x minus 3 over an x plus 3, my first step would be to totally rewrite the problem as a multiplication problem. It becomes multiplication when the second fraction, not the first, but the second fraction gets turned upside down and made into its reciprocal. Now we're back to where we were here and here. The x squared minus 6x plus 9 is an x minus 3 and an x minus 3. Here an x factors out and you got an x plus 3. And over here it's already prime. So what happens is the x plus 3 cancels the x plus 3. And x minus 3 cancels one of the x minus 3's. All you're left with is x minus 3 over x. So again, the division problems will immediately become multiplication problems. Let's work at least one more division problem. Let's go with a 4a squared plus 4a plus 1 over 4 minus a 9a squared. We're going to divide that by a 4a squared plus a 2a over 3a minus 2. And let's see what happens with that. Again, division has immediately going to have to turn into multiplication. So the 3a minus 2 will go to the top. The 4a squared plus 2a will go to the bottom. And now we're ready to do some factoring. First one's a trinomial. It'll become two binomials. A 2a, plus 1, a plus 1. The first denominator becomes a 2 minus 3a and a 2 plus a 3a, difference of squares of course, times the 3a minus 2 over, down here a 2a will factor out, don't forget the GCF, leaving behind a 2a plus 1. Alright, let's see what we can cancel. 2a plus 1 cancels 2a plus 1. Let's see, a 2 minus 3a and a 3a minus 2 will cancel, even though they're not the same, leaving behind a negative 1. And so what we have is negative 1 times a 2a, negative 1 times a 1 is a minus 1. Just multiplying it out over a 2a times a 3a plus 2. Just basically turning that around into a better order. Now you could leave this factored out, or you can multiply it back out. Either way, it's really not going to matter. There is your division problem completely simplified.